Yes guys, welcome to another video. Today we are going to be focusing on how to make Hangman in Android Studio using our favorite programming language, which is Kotlin. So without further ado, let's get straight into it. I have over here an emulator that's got the application running. You can see that the text view that says Hangman and a button. When I click over here, it takes me over to the game. I can see the image view over here that will be changing as the player gets the letters wrong. The actual word that we do need to guess, the letters that we have used, a button that says start new game, and at the very bottom we've got all of the letters in the English alphabet. And as we click these, we see the letters used being populated. So if I click on Z, it puts Z at the very end, but I'm not going to try. Yeah, it's Senegal. I knew that. No, I didn't. So yeah, if you lost the game, then it shows the words you lost in red with an exclamation mark, and then it hides all of the letters. And for me to start the new game, I need to click on this button over here, and then we can start a new game, and so on and so forth. So that's pretty much the game. So how did I do this? Well, first what I did was I created a bunch of images in Photoshop that have got the exact same dimensions, and what I did was I basically created different layers in Photoshop, and I would basically I would export the PNG of that specific layer and save them into Android Studio. Then I created a main activity class, which is super simple. If I go to the XML file, it's just a text view at the very top. It is a constraint layout, so I just say text equals Hangman and then the text size. And then I created a button which has got the text value play and then give it an ID and obviously some constraints. Now, if you were to create quote unquote a proper application, you wouldn't really hard code the text here or the size or even some of the styles. You would extract these over to the styles folder, which is inside the values, inside themes or styles. I forget which one it is off the top of my head, but in essence, you would have these themes and styles defined somewhere so that you can reuse these instead of having repeated XML styles like text size and style and font family and text color and then background color. It basically saves you with a lot of code. And also, if you ever change your mind and you want to change like one component, you don't have to go through the entire project and then change it for every view. You can just change it in the style, and then that will propagate the changes across the whole application. Okay, so yeah, as I mentioned, the main activity has got a button. You click it, it goes over to the game activity. So the game activity will basically show this layout as I showed you in the emulator over here. This is very simply the image view at the very top. This obviously changes, but the very beginning image view is game 0. Okay, and yeah, beneath this we've got the game lost. Well, actually, sorry, it's not beneath it. It's beneath it in terms of the positioning, but it's constrained to be at the very center of this image view, and you can see that because the constraints are bottom to the bottom, end to the end, start to the start, top to the top of the image view. And you can kind of think of it as a tug of war, where the left of it and the right, the top and the bottom are the left and right, top and bottom of this image view. So that it just kind of fights and it places itself right in the middle. And the same thing is for the one text view, which is exactly the same as this. The only difference is that one says you lost and the other says you won, and of course the ID is different. And again, you wouldn't really have, you know, these text color and text size and style inside each one. You would have a separate style that you reference, so then you don't have to keep on referencing, well, rather keep on repeating yourself over and over as I have done. But it's a simple application and it's fine to have it like this. And then we have a text view for the actual underscores. that's the word that we are guessing, and as we guess letters, they will appear here. And then we have the letters used, which is a text view. Oh, I can delete that. Goodbye. And then we have a new game button, which if you click on it, it basically resets the game. You can see over here I've actually extracted the string, which is a good practice, and it tells you what the value is. And if I do command minus, it collapses it and it tells me what the value is as well. Again, this has also got constraints, and then at the very bottom I have got a constraint layout which has got all of the letters in the alphabet. Interestingly, I have added a widget called floor, and what it does is it will basically, if you reference all of the views as I have done, so each text view over here has got an ID that corresponds to the letter, right? So inside over here in the floor, I've simply referenced all of the views A, B, C, and D all the way to Z, or Z if that's how you say it, and I've given this wrap mode aligned because it will basically align everything to the left. Okay, if I say chain, then it will basically make everything center justified, and it will kind of like squash it, towards the middle. And you can see that at the bottom where everything's equally padded out, but the two lines above, they kind of are flush up against the edge because there's padding. And that's pretty much, yeah, that's the purpose of floor. It is a constraint layout widget, so we trust it in that way, I guess. There's a few other third-party libraries that do the exact same thing, but I kind of went with floor because it's easy to use and it's tried and tested. Cool, okay, so that's the layout for the game activity. So let's go back over here. So those views that I have mentioned, I've basically added them over here, and I simply use find view by ID to bind them to the property inside this game activity. I do have a game manager class, which I will be talking about in just a second. But yeah, the new game button, we simply say set on click listener and then start new game. So let's go, well actually let's not go there just yet. What I do here is I say game manager dot start new game. So let's go over there. What does this do? It basically resets all of the variables that are inside this class. So this class, it maintains the letters that the user has guessed, the underscore word, so that's the actual underscore that you see over here. So if we try to guess a letter correctly, so yeah, I is used twice over here. So this underscore word will be underscore 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 I underscore I underscore. Okay, and the word to guess will be the actual correct word. The max tries is 7 because that's the most amount of tries that the person has got. And the current tries, that basically increments as the person incorrectly guesses. And then we have a drawable, which keeps a track of the actual drawable. So start new game essentially gets a random number from 0 to the size of this variable. So this is a separate class that's over here called game constants, as you can see, and it has got the list of all of the countries. And I've basically replaced a space, so these would generally would look like this, but I've replaced them with a / so that it's easier for the user to see. Like if I click on start new game, this word, well, this country has got 3 words inside of it. That's probably and. Yeah, A, N, D, right? In actual fact, I think it's, yeah, I think it's that. Antigua. G, U, B, R, and there you have it. I won, albeit I cheated, but who cares? So Yeah, so that gets a random integer, and then what we say is we say go to the words and pull out me that specific word at this index. And we need it to be random because we don't want to play the game with the same word, because that would be very, very boring. So yeah, once we get that word, we pass it over to this function called generate underscores. And what it does is it loops through the word. So if the word is, I don't know, Spain, SPAIN, it will create 5 underscores. And as I mentioned, if there's a space, we have replaced it with the forward slash. So that's what we're doing here. We say if the character is a forward slash, then append forward slash. And then finally, we say string builder.toString to convert it into a string and then pass that value into the underscore word. Once we have that, then we return the game state. And the game state basically checks does the word, well, for now, I'll skip this for now, but it basically returns this over here, which is running. Okay, and then once that has been done, let's come back to the game activity. We then say update UI, and update UI performs a when statement on the game state, and then we basically check has the game been lost. If it is, then call the show game lost function by passing in the game state. Now, game state is a sealed class which can either be running, lost, or won. And sealed classes are really good because they allow us to easily map out state. So the game state, like literally, can either be like running, or lost, or won. And we can have like different variables and properties inside each one, even though they all extend game state, right? So inside our class over here, we say when the game state, and it can either be one of these things. And the compiler knows that it can only ever be these things because I believe you can't extend a sealed class outside of the same file. So it just knows that it's going to be one of these three. These are the 3 options. And then it does something what's called smart casting, which is you can see that that the running class, which is a game state, it has got 3 properties, but lost and won only have 1 property. And what's interesting is that inside this branch over here, we can access the game state's underscore word, letters used, and finally the drawable, and it doesn't complain. Whereas if I just copy that code there, and if I just make this into a branch like this, and then if I was to do this, it's gonna complain and say it's unresolved. I don't know what you mean by letters used. But interestingly enough, it doesn't do that for the running branch, and that's because of smart casting. And I believe if I just hover over, yeah, you can see it says smart cast to game state running. So yeah, seed classes are very, very powerful and they're super helpful. And in this specific case, they're better than enums. So yeah, I've used this update UI, where I pass in the game state. I check when the game state is lost, call the game lost function. When it's running, and I am being a bit naughty here. What I should be doing is extracting this out to a separate function called show game running, right? Where it contains this exact same code. But yeah, so if it's running, then we update the text for the word. That word text view is the underscore, and then the letters used, we append that as well with the letters used and then the actual value, and then we change the drawable. And if it's 1, we basically call the show game 1 function. We call it. So let's have a quick look at these functions. Very simply, we whether it's win or lose, we show word to guess. We make the lost, text view visible if the game is lost, and we show the game won text view visible if the game has if the user has won. And excuse me, we make the letters layout invisible, and then we call, yeah, so that's for running. If it's if it's I think that's pretty much self-explanatory actually, yeah. So that's that, and then start new game. This gets called by obviously the button that we press. It resets everything by setting the game lost and one text views to gone, so they are no longer visible. We start a new game, which I covered just earlier before, and then we make the letters layout visible. And we don't just do that, but we make each individual letter inside that layout visible as well, because if I come over here, well, actually, just before I go there, we do update the UI with the game state that is attained from the start new game. But at the beginning over here, we inside the onCreate function, we basically loop through all of the views inside letters layout, and we first check, is the child that we're currently indexing in this for each loop, is it a text view? If it is, then create a onClick listener where I get the letter that's inside that view. So if we click on A, then this will be A. The reason why we say at index 0 is because .text inside a text view gives us back a char sequence similar to a string, but the play function requires a char and not a string. So we pull out the first index, which is a char, and then we call the gameplay. Now what this does is that it first checks, does the letter that's been passed in, is that already inside the letters used? If it is, then just return the state running, and the reason why is because we don't want to call the same logic for the same letter. So for example, I know we can't do it now because I've changed it a little bit, but before I wasn't hiding the letters, so I guess I could remove it, but for now I've just kept it there. So if I click on A, and then if I clicked on A again, what it would do is it wouldn't continue with any of this logic, it would just kind of return the exact same state. So whatever the letters used and the underscore word and the drawable is, just return those. However, if that is not the case, and if I clicked on D, for example, so that was part of the word, then what I would do is I would say letters used plus equals the letter, and well, I think I don't even need to do that. I think I can just do that. Yeah. So letters used plus equals letter, and then I create a collection of indices. I then loop through the word to guess, and what I do is I check whether I check at each index, is the letter that I have that I am guessing, is it any of the letters that are inside this word? If that is the case, then I basically add that index to that word. Sorry, this collection. So say for example the word that I'm trying to guess is England, and I guessed the letter E. So therefore the index here, it will be 0, and it will add the value 0 over to this collection. And then what I do is I simply say, I basically create a new string, and I assign it to underscore word. And the reason why I do that is because if I just assign it to underscore word, then if I was to make any changes to final underscore word, then this variable also changes, and that's what I don't want. Maybe I can optimize this afterwards so that it doesn't need to do this, but for now I've just kept it as this. And it essentially loops through the indices, and then it creates a string builder. And it basically, so if the word was England, you would have these underscores, and because the index is 0, what it does is it basically gets that word, it gets these underscores, and it replaces the letter that we are guessing, which is E, at that index. So this becomes this, and then we say final underscore word equals this string builder dot toString, and then afterwards we say indexes. If it's empty, if the indices are empty, it means that we have incorrectly guessed a letter, and we say current tries plus plus. And then finally we make the property that's at class level equal to this this logic that we have got over here. We say underscore word equals the final underscore word, and then we call get game state, and then we return that. So let's have a quick look at what game state is. So yeah, so here we check, is the underscore word equal to the word that we need to guess, and then we ignore whether it's capital or not. If that is the case, that means that the person has correctly guessed the word, and we return an instance of the GameState1 class, and then we pass in the word to guess, to then show onto the screen what the word is. If that is not the case, we check, are the current tries equal to the max tries, which means that the person has lost the game. And again, we pass over the word to guess because we want to show what the word is even when the person has lost. Right, so if I was to purposely lose over here by adding a bunch of extreme letters, so yeah, it was Sudan and I guessed these letters, the max tries reach 7, it's going to say that I've lost. Okay, so if I haven't won and if I haven't lost, then it means that the game is still running. So then what I do is I go and get the Hangman drawable. So this is a function, and similarly I say when the current tries is 0, then return the game 0 picture, which if we look at these and click on browse, you can see that the game 0 is the very first image, and then 1 is this one. So I've basically added all of these from Photoshop, and then we put that drawable inside this running class, and then we return this instance by passing in the letters used and the underscore word. So if I just go back over here, so once I get that game state, I then call update UI, which is over here, which we've explained, and then we basically make that letter invisible, or we make it disappear, we make it gone, so that the person can't guess the same one. So you can see these are disappearing as I keep on guessing. And that's pretty much it. We do have a start new game again, which kind of resets everything, and then it updates the UI based on the on the new game state. But yeah, there's like so many different optimizations that we can make. We can make the code cleaner and better, but this was a quick example of how to make Hangman. If you did like this and you want to see more videos, please do let me know in the comments what you would like to see. I will be uploading this code onto GitHub, and I will post a link into the description for you guys to download and to play around with. Feel free to change the code as you want, and let me know if you change anything. It'll be good to know what you guys come up with. So thanks for watching, and I'll see you in the next video.